Alright folks, I wanted to make a video about the performance task. And the performance task is on ratios and percentages. And I'm going to review this later and make sure that noise from my children is not so loud it's distracting. So this is, I believe, last year's, 18 to 19's performance task. And it is all about ratios and percents. So, let's get started. Use the information given to answer questions 1 through 8. Valeria and Ned travel to Denver, Colorado from Niagara Falls in Ontario, Canada. They've stopped to get gas for their car a total of 5 times. This table shows locations, the cost, and the amount of gasoline they purchase at every stop. A note, CAD is the abbreviation for Canadian dollars, which is a currency used in Canada. Here's a graph showing the relationship between liters, that's across the bottom here, and gallons, that's up the side. So this question has 2 parts. First, answer part A, then answer part B. While getting gasoline in Canada, Valerie and Ned are not familiar with liters. Oh, look, see, it's a different unit than these guys. So they consult the graph that shows the relationship between liters and gallons. So it says over here, for 1 liter, it's 0.264 gallons. That's what this means. An ordered pair is always the, I call it X and Y usually, but in this case we've got the horizontal being liters and the vertical being gallons. So you could think of it as the number of liters, comma, the number of gallons. And because it's a proportional relationship, I mean, it's just a conversion factor. If I have 2 liters, I'm going to have twice that number of gallons. So 0.518, 528. Can't think. Children screaming. All right, it says, what's the meaning of this point? 1, comma, 0.264. So the first number is always the number of whatever's across the bottom, the horizontal direction. So there's 1 liter, and the second number has always got to do with the vertical axis, gallons. So 1 liter for 0.264 gallons. And I've been talking with the kids about the actual name of decimals, so it's 1 liter for every 264 thousandths of a gallon. So 1 liter is equivalent to that many gallons. That's exactly what it means right there. There's option C. It says that many gallons is equivalent to that many liters. That makes no sense. A gallon is equivalent to that many liters. Well, that would be true if the number 1 were on the vertical, the number 1 were the second number, but it's not. And a liter is not equivalent to a gallon. Okay? On the graph, this is called the unit rate. Per 1 liter, that's how many gallons you got. So it's another way of thinking about the unit rate. Some places might call it a conversion factor. So for every one of these, I can multiply by that number, and I'll get how many gallons. You can also think about the constant of proportionality. It's another way of saying it. Constant of proportionality is this 0.264. If I were to say, write an equation for the relationship between liters and gallons, the number of gallons I have equals 0.264 times the number of liters I have. That right there is your constant of proportionality. Your constant of variation is also called. It's your unit rate. It's the constant part. This number does not change. If I had 20 liters, I multiply it by the same number to find the number of gallons as if I had like 500 liters. It always is the same. It's also called the slope in this case. For every 1 I go over, I go up 0.264. And it doesn't really look like that because you look at this, it looks like a square. It looks like a over 1, up 1. But look at the way it's labeled. Over 1 is up a little more than 0.25. A little more than a quarter. 1 is all the way up here on the scale. So it's not a 1-to-1 scale, it's a 1 to a quarter. All right, part B. Which statement about the graph shows the relationship between liters and gallons? That shows the relationship is true. Which one of these is true? 0, 0. 0, 0 is a point on the graph. Anytime you have proportional relationships, you have the point 0, 0 on your graph, and you have a straight line. So the point 0, 0 means if I have 0 liters, I got 0 gallons. That makes sense. I mean, 0 liters, 0 gallons. A gallon is equivalent to a liter. No. The fact that 0 liters is equivalent to 0 gallons, yes. It's not a unit rate. If it's a unit rate, you'd have a 1 right there. And the unit rate of liters per gallon, oh, hold on, gallons per liter. Yep. Liters per gallon, you'd have the unit right there. Oh, so it's B. All right, let's look at this sentence. Valerie and Ned purchased 12 liters of gas in Canada, which is equivalent to, oof, we got to pick one. If 12 liters of gas, so 12 liters of gas. Let's look back at the graph. 12 liters would have been over here somewhere. It would have been somewhere up here on the graph, so it would be something about more than 2.75, but probably not more than 4. My guess is it would be about 3.168. But let's find out. We know to get the number of gallons, we're going to multiply 0.264 times the number of liters. So if I have 12 liters, that's 0.264 times 12. And let me see if I got a calculator. Oh, I do. 0.264 times 12. That's 3.168. That's the second option. So you'd pick that guy if it was a drop-down menu. Number 3's got 2 parts. All right. The relationship between the cost in dollars, and we're saying the cost is Y. And I haven't been annotating a lot, but if you need to annotate, absolutely do so. The cost Y in dollars of gallons and the number of gallons X sold in Columbus, Ohio can be modeled by proportional equations. So what's my equation? We've got to find a unit rate. Let's look. We're looking at Columbus, Ohio. Columbus, Ohio. So this is question 3 we're looking at. Columbus, Ohio is the second one over here. So right there. That's where we're at. Okay. 33, 35, and we bought 11.5 gallons. So we want to know the cost per gallon. Okay. So let's put the cost per gallon. Whatever's on top is the word before the per. Whatever's on bottom is the word after the per. So the cost was $33.35. $33.35. And that's for 11.5 gallons. And if we want to make a proportional relationship for 1 gallon, how do we go from 11.5 to 1? And this is where you think about, well, do I need to multiply it by a number or divide it by a number? 11.5 is bigger than 1, so let's divide it by itself. And that'll turn it into 1. Whatever I do on the bottom here, I got to do on the top here to make it a 1. So we got to divide by 11.5. Because I can't multiply or divide by something that's not 1. It's going to change the value. 33.35 divided by 11.5. Let's see what we got. 2.9. So right here, that's my unit rate of cost per gallon. So if Y is my cost and X is my gallons, I have to multiply by that unit rate, 2.9, to figure out how much the whole thing costs. Oh, part B says, how much do 5 gallons cost? If you haven't cleared your calculator yet, and this works even on little blues, this is something that's the same. If you haven't cleared that out yet, if you hit times on your little blues, it'll multiply that number times whatever you put next. On mine, it'll show you what it's thinking when you do that. I hit times, it says answer. That refers to my last thing. Times 5 is 14.5. So my unit rate, 2.9, you can think of it this way, 2.9 for 1 gallon equals how much for 5? To get from 1 to 5, since 1 is smaller, let's multiply. It's a 1. We're going to times it by 5 to get 5. Do the same thing on top. That'll give you multiplying by a factor of 1. It's supposed to look like a 1 when you put the box around it. I saw that today. It was kind of cute. Anyways, that times 5 is $14.5 for 5 gallons. It's good to put the units in there. I know I'm saying them when I'm writing them, but if you don't write them down, you might lose track of what's going on. So $14.50. I'm going to take a pause here so my video is not too big for YouTube.